Okay, first question, question 1. The mean and the variance for question 1. Can anybody give me any answers for that one? What's somebody got for the mean for part A?
1.83.
1.83 is correct, yeah, that's 1 and 5 6. So there we go. The expectation, which is what the mean is each x value times by its probability and add them up. So 1 and 5 6 or 1.83. So if you got that bit right, would you be brave enough to give an answer for the variance one as well? We've got a 0.47, let's have a look. It could well be, I've got 17 over 36, so if somebody works that out as a decimal, okay, it is just under half, because 18 over 36 would be a half, so it's just under 0.5. So for the variance, you had to work out the expectation of x squared, which was the square of every x value times by its probability. Add those up, so that gave you the expectation of x squared. Then from that you had to take away the expectation of x all squared. So has anybody checked what that is as a decimal?
Yeah.
What was it again?
0.472.
0.472 as a decimal. Okay? Right, so if that's part A, part B, we had another table. Anybody know what the answer is for part B? Expectation? 0. Yeah, that's correct. And the variance? Sorry? The variance isn't 0, it's a half, yeah. For that one, for part B, if I just put that up here, the expectation would have been minus 1 times a quarter, 0 times a half, and 1 times a quarter. 0 times anything is 0. When you're timesing those together, you're going to get minus a quarter. When you times the ones on the right together, you're going to get plus a quarter, and they cancel out, so that's why that's 0. Expectation of x squared was a half, and then the variance would have been that number, take away that one squared. So that came out to be a half as well.
How is 0 squared a half?
It isn't. It's this one here that gets... Sorry, it's that one there, the expectation of x squared, take away the square of the 0. So it's a half, take away 0 squared. A half take away 0, which is a half.
But surely that expectation of x is the same as you surely just square that 0.
No, this is the important thing, okay? The expectation of x squared is each x value squared times by its probability and added up. The expectation of x is each x value times by its probability not being squared and added up. And one thing we said before is that the expectation of x squared is not the same as the expectation of x all squared. Or if it is, it's a fluke just in that particular set of numbers. But generally, that is not true. So the expectation of x was that times that, that times that, that times that, added up. Expectation of x squared is that squared.
Oh, okay,
so that squared gives you a plus 1. So that's why that they don't cancel out on that one. So it's this one here, take away that one squared. Part C, similar sort of thing happens. Is anybody brave enough to offer an answer for part C?
Minus half.
Minus a half is correct, yep, for the expected value. It's minus a half. The variance is 2 1/4, and you will have needed to do the expectation of x squared part way through there, which is 2 1/2. So, the way I'm going to mark this, if I just show all of those answers together a minute on the board. For the marking of this one, can we give 1 mark for the expected value of x in each one? So that's the expected value of x in each one, can we give a mark? And for the variance for each one, can we give 2 marks? And there's a method, so I put that in the wrong place. The variance, 2 marks. And if you haven't got that right, but you've got the expectation of x, then that's 1 method mark. So it's 3 marks for each bit. 1 for the mean, 2 for the variance. If you haven't got the full 2 marks for the variance, but you've got the expectation of x squared, give yourself a method mark. So altogether it's 1 mark followed by 2 marks. So altogether that question's going to be out of 9.